Hello, and welcome to the lesson on finding special products of polynomials. So this lesson is focused on these special patterns we're going to see that don't really come in that handy in this lesson, but when we start factoring and we're doing the reverse of this multiplication, it actually does come in a little bit more handy. So take a second, see if you can find the mistakes in the problems below. All right, so this one, it looks like they tried to add when they should have multiplied. Like if you take x plus x, you get 2x, and -1 plus a +1 would be 0, but that's not right. This is a multiplication, so you should get x squared plus x minus x minus 1. And then when you simplify that all, you get x squared minus 1. This one over here, well, it looks like they multiplied. I mean, because that would be an x squared. That would be a minus 3x, which might be a problem because I'm seeing a plus 6 here. So let's see. There's another minus 3x, and finally a plus 9. So yeah, actually it looks like the only mistake was this here. When they combine those together, a -3 and a -3, they got plus 6x somehow, and it should just be a and it should just be a minus 6. So that sign right there was the mistake. Vocabulary, and don't worry about this vocabulary too much. I mean, a binomial square pattern, it's a pattern that can be used when taking a binomial and squaring it. This means probably very little to you right now. This will mean a lot more in practice, and honestly, we're probably never going to look at this page again. But these are some of the vocabulary, the things that we're going to be talking about. We're talking about a pattern when you have something that's squared. A binomial is this dude. So this dude squared. And this is kind of what it's going to look like when we multiply it out. And then there's also the sum and difference pattern. It looks like this. And then the result is going to look like something like that. Okay, so don't worry too much. It makes much more sense in practice. So this would be this binomial square pattern. You're taking a binomial, there's two terms, and you're squaring it. You're multiplying it by itself. Now, I'll be honest with you, I do not like you folks to have to remember that pattern from the formula sheet, or from the vocabulary. Like, imagine you're trying to remember, which one was it? Minus this. And you're going to try to fit what was ever down here. I'm trying to get both things on the screen. There you go. You're trying to fit this thing here into like this pattern. It's ugly when it's so much easier just to go x minus 5, x minus 5, because that's the thing squared, like it's times by itself, and that's supposed to be a parenthesis out front, not a 1. So you're taking the thing and you're squaring it, and then you just multiply, just like we did in the previous lesson. So we're going to get x squared minus 5x. I never give myself enough space. Minus 5x plus 25. Combine like terms. X squared minus 10x plus 25. And we're done. This is the pattern from the vocabulary. It says you take this piece and you square it. It says you take this piece and you square it. And then it says you take 2 times these pieces multiplied together. So 2 times a -5x. And that's not a great way of showing that. 2 times a negative, I'm out of -5x. There you go. And that's that piece there. So that's what the pattern in the vocabulary box is trying to show you. It's just a very ugly way of doing it, where if you just multiply like normal, there's nothing to worry about. You don't have anything new to remember. It's like here. I'm just going to write 3x minus 2y times 3x minus 2y. I'm going to take the thing and square it, multiply it by itself. So I'm going to multiply my firsts, 9x. I'm going to multiply my, that is what? 6xy. 2 times by the 3 is the 6. X times y is xy. Now when I multiply by the negative 2y, I'm going to get a negative 6xy. Well, this also should have been negative. I missed my sign though. And a positive 4y squared. I think I forgot the squared on my 9x. This should be 9x squared as well. And then I simplify. So now I'm going to have 9x squared minus 12xy plus 4y squared. And there's no rearranging of this needed because each of these terms is a second degree. They all have an exponent of 2. Exponent of 2, 1 and 1 makes 2. Y squared makes 2. So they're all the same degree, so the order is less important, and this is kind of alphabetical. So that's actually how you'd see the answer most likely. So moral of the story, don't get bent out of shape about the vocabulary and trying to remember the pattern. Just write it out and multiply. So really this lesson comes down to just more practice multiplication. So why don't you go ahead and pause the video and try these two right now, please. Oops. All right, so let's change over to red for us. So this becomes 2x minus 5 times by 2x minus 5. That gives us 4x squared minus 10x minus 10x plus 25. My middle terms combine into a negative 20x, and everything else comes along for the ride. Letter D. 5m plus 4g times 5m plus 4g. And we multiply. 25m squared plus 20mg. I was deciding whether I should make it a gm or an mg, and it doesn't really matter. And then we have another positive 20mg and a positive 16g squared. My middle terms combined together, 25m squared plus 40mg plus 16g squared is our final answer. Now if you rearrange this and made it 16g squared plus 40 gm plus 25m squared, that's also acceptable. This, I don't know which one a textbook would show. I mean, this is the one that has the variables in alphabetical order, so you have the g's first. Even here, like we switch the g and the m, instead of mg is gm, which is perfectly fine because you're allowed to do that inside of a multiplication. You're allowed to change the order of the terms. That's the commutative property of multiplication. And then we put the m last. So both of these are equivalent. Okay, now that was the square pattern where we had something that was squared and we had to just write it out ourselves, separate it out into two separate pieces, and then multiply. This is the sum and difference pattern. You can recognize it because the two terms are almost identical, except one is a plus and one is a minus. That's why it's called the sum and difference pattern. And then what makes these special is your middle term here will cancel out. You will not have a middle term in your final answer. So let's see what that looks like. x squared plus 5x minus 5x minus 25. My middle terms here are going to cancel out. Give me a second to get a drink. There we go. Is it better? Yeah, feels like it. So my middle terms cancel out. I have a positive 5x and a minus 5x. So I'm going to get x squared minus 25. And that's it. But really all we did was we just multiplied like normal. We didn't really do anything special, but the end result is a little special. The fact that we don't have this middle term is a feature of this sum and difference pattern. So each of the next bunch of problems will follow that same thing, like when I multiply here and here. 4x squared minus 6xy. When we multiply the 3y through, we're going to get positive 6xy, which is how those two middle terms cancel out. One's a plus and one's a minus. And a negative 9y squared. So then when we finally do simplify, we get 4x squared minus 9y squared. So it's really not worth your time to try to remember these patterns. As long as you can multiply, the patterns will reveal themselves and you'll be good. Okay, why don't you go ahead and pause the video and do these two on your own right now, please. All right, so this would be boom, boom, 4p squared plus 4p minus 4p minus 4. 4p squared comes along for the ride. These p's in the middle cancel, and our minus 4 comes along for the ride. Ba-boom, ba-boom. M squared plus 4mk minus 4. Even if I put km, we're still good. I'm going to show you because that can be confusing for some folks. Minus 16k squared. Now this mk and km here in the middle, again, you're allowed to change the order of the variables because this whole thing, these three pieces, the 4, the k, the m, are all being multiplied together. And the commutative property of multiplication says you're allowed to change the order of multiplication and still get the same answer. That's why like 3 times 4 is the same thing as 4 times 3. So I would recommend that if you see this, you're allowed to rearrange them. So I would make them all the same, even if it's not in alphabetical order. Make them at least the same. So now there's mk's and mk's. Now you can see, oh yeah, they do cancel. So we get just m squared minus 16k squared. In summary, this is a very short lesson. How can knowing the special patterns help us to multiply polynomials? Give a little a pause and try to see if you can answer that question. How can knowing those special patterns help you? Well, it can act like a little shortcut. If you know what the pattern is going to be, you can easily shortcut and go, okay, I know the middle term is going to cancel out, so this final answer is just going to be the first term squared and just the lasts, or the firsts multiply together and the lasts multiply together. There's no middle term. So it can shortcut you that way. If you recognize this square pattern, binomial square pattern, you could kind of shortcut the process a little bit, but I'll be honest with you, I don't think it's worth your effort trying to memorize this to save you 3 seconds on a problem. it's probably more worth your while just to get the practice of multiplying and working your way through the problem. Okay? So, thank you much for watching this lesson. Until next time, toodles.